Okay, welcome to Introduction to C Programming. Today we are going to talk about repetition statements, specifically the while loops. With repetition statements, they allow you to specify that an action is to be repeated while some condition remains true. As long as the condition remains true, we are going to continue looping and executing the body of the loop, of the while loop. While statement is just one type of repetition statement. We're going to talk about two other types, which is a do while and a for loop. And we'll talk about those in our next lecture. So let's take a look at this code that I have on this slide. You see that I start off with an int variable named product, and I set the value equal to 2. After that, I have my while loop, and I say while the value of product is less than or equal to 1,000. You see the syntax of a while loop there? Looks very, very similar to the syntax of an if statement. So the while loop, instead of saying if, I'm going to say while, and then I open the parentheses, and this is just any kind of a condition. Any condition that I had for my if statement, I could also have here for my while loop. So this could have ands, ors, equality, inequalities, ranges, and so on. Any condition like that also is going to be valid inside of the condition of a while loop. I open the parenthesis, put my condition, close the parenthesis, and then I open the curly brace. Everything that is inside the open curly brace and the closed curly brace is called the body of the while loop. So that is what is going to be executed as long as the condition is true. When I come down to the while loop, the first thing it does is check the condition. If the condition is false from the get-go, I never am going to execute the body of the while loop. It will just jump down outside of the while loop and execute the next line of code immediately following it. In this case, for the code that I have on the slide, you see that it is actually going to get inside because the value of product is 2, and 2 is less than or equal to 1,000. So it gets inside and it says product equals 2 times product. So what will happen there is it's going to take the value of product, which is 2, it's going to multiply it by 2, make it 4, reassign it back into the product variable, so product is now going to be 4. So let me write this up here on the slide on the whiteboard so we can see what's going to happen. So here is the value of product. So product starts off at 2, and here I'm going to say what gets printed. Okay, so the value of product starts off at 2, and then I come in there and I say, okay, the value of product becomes 2 times product, which becomes 4, and then I print out the value of product, so I print out a 4. I come back up to the top and I say while product is less than or equal to 1,000. Well, at this point it is, because the value of product is 4. 4 is less than or equal to 1,000. When I multiply it by 2, I get an 8, and then I say print out the value of product, which is 8. I come back up and I say while product is less than or equal to 1,000. 8 is less than or equal to 1,000, so it's going to multiply 8 by 2, which gives me a 16, and then it prints 16. You kind of see what's happening. While product is less than or equal to 1,000, it is then going to multiply it by 2, which makes it 32, and it prints 32. Product 32 is less than or equal to 1,000, so it makes it 64 and prints 64. 64 is less than or equal to 1,000 and makes it 128, and then it prints 128. 128 is less than or equal to 1,000, makes it 256, it prints 256. 256 is less than or equal to 1,000, it makes it 512, and then prints 512. 512 is less than or equal to 1,000, it takes 512, multiplies it by 2, makes it 1024. It then prints 1024. It then comes up and says while product is less than or equal to 1,000. Well, 1024 is not less than or equal to 1,000, so it breaks out of the loop. However, the very next line of code after that right here is printf the value of product. So what does it do? It prints 1,024 a second time. So the output from this code here is it's going to print the powers of 2 starting at 4 all the way up to 1,024, and then it prints 1,024 a second time at the end because I have that line of code there. On the next slide, you're going to see this exact same output if you had trouble reading what I wrote behind me here on the whiteboard. So there is the output that we got from running that program on the previous slide. Okay, this first bullet point that I have on this slide is probably one of the most important things in this lecture. Keep this in mind, it is extremely important. Your loop will eventually terminate, meaning that the condition becomes false at some point. or you exit the loop on some condition in the body, such as with a break statement. This is extremely important that we have what's known as a stop condition. Otherwise, our program is going to loop forever. Now, having said that, there are some programs that we do want to loop forever. These are often server programs. Web servers, we don't ever want to die. We never want the web server to die. We want the web server to always be able to service requests. The way that we terminate a program like that is that we actually have to kill it manually. So we would go onto the server and then we would kill that program, rather than having the program terminate after every web request, let's say. So there are some programs that we do want to run forever. However, most of the programs, or maybe even all the programs that you're going to write in this class, you're not going to want to run forever. So you want to make sure that it's extremely important that your loop will eventually terminate. You need to make sure you always have a stop condition. If you don't, make sure you understand that your program is going to loop forever. There is another terminology is a sentinel controlled repetition. If you don't know how many times your program is going to loop, but you do know that the loop will stop when a specific value is entered, this is known as a sentinel controlled repetition. We often do this with asking the user enter value or enter Q when you're done. So they just keep entering values. We have no idea how many values they're going to enter. However, when they're done, they're going to enter Q. And so that's known as a sentinel controlled repetition, because we don't know how many values we're actually going to get. However, we've told the user, when you're done, enter Q. So our program is not going to move on. We're going to be looping constantly until we get the value Q. And if we don't, we're just going to keep looping and keep looping and keep looping. Eventually, the user gets the point. And that hopefully they are going to enter a Q so that we can move to the very next line of code after our loop. Okay, typecasting. When you this doesn't necessarily have to do with loops. That's what we have on while loops. They're really not that difficult to do. We can nest while loops. You can have while loops inside of while loops, and you'll have to do that for one of your programs coming up. But we're going to talk more about loops in our next lecture, which is on for loops and do while loops. So I just have two more slides, or a couple more slides here that I wanted to talk about, so that you can hopefully write a little bit more if you've had trouble outputting some values. So when we perform division of an integer by an integer, we always get an integer. However, what if we wanted to produce a float? Like in this case here, when we have int num equals 10 and we have num2 is equal to 3. Well, when we divide num by num2, this is an integer divided by an integer. What we're going to get is an integer. 10 divided by 3 actually is going to give me 3. It doesn't round, it just gives me the value and it chops off the decimal. So it's not going to give me the actual value, even though I'm setting it equal to a float. So you'd think that maybe when I do this division, I'm actually going to get the right answer. But no, what I'm going to get is 3.0. Because an integer divided by an integer is going to give me an integer. If instead I actually wanted to get the float value, the floating point value back from that division, I have to do something called typecasting. I can typecast variables to other variable types. You have to be careful when you do this, though. In this case here, you see that I have so down here at the bottom, I have num, which is being typecast to a float, and then num2 is being typecast to a float. Well, when I typecast an integer to a float, I'm just going to be appending a decimal place and zeros after it. So I'm going to get 10.0 divided by 3.0. They're both going to be floating point values. When I divide a float by a float, I get a float. So now I'm actually going to get what I was expecting to, which is 3.33333, and so on, and up to the precision of a float. How many decimal places I'll have there? I think it's 6 decimal places is the default for a float that you would see there. You can typecast the other way also. You can typecast a float to an int. When you do that, it's just going to chop the decimal place off those. So if you had a floating point number and you needed to make an int, you could do that. You're going to typecast it the same way, just inside of these parentheses, you would have the word int instead of float. When you typecast, it has to be immediately before the name of the variable that you're typecasting. You put what you're typecasting inside of the parentheses. So I have float. I'm typecasting my variable num to a float. So I have to put the parentheses around float, the type, and then I have the name of the variable that I am typecasting immediately following that. And it's going to typecast num to a float. If you are unable to typecast, then your program will unfortunately still compile. However, you will end up with a runtime error. So if you try to typecast something from one type to another type that is not able to be typecast to, then you will get a runtime error. Your program will still compile, but it will crash when it gets to that line of code when you're running it. You probably won't see that when you're dealing with the numeric data types because those can be typecast back and forth to each other. You will see that instead when we get to structures, or when you learn about C++ or Java and you start typecasting objects, which are classes. That's when you'll probably get to more problems with that. Okay, if we want to print with precision, some of you may have had this problem where you haven't been able to print with precision, that your values, your floating point values, all have 6 decimal places after them. If you want to print with precision, you use the printf function inside of it. Instead of just saying %f, we're going to say % followed by a decimal place followed by a number, and that is going to tell us how many decimal places you want on your floating point number that you're outputting. So %.2f on fnum is going to tell us that we want to have 2 decimal places after our variable. Okay, that's it. Kind of a short lecture for while loops. That's it for this one, though. Look at the next one where we're going to be writing a program using it. It's going to be kind of a longer program where we're going to use some while loops. All right, talk to you then.